to solve the second internal paper of data science. Our first question is write algorithm for decision tree induction. So our algorithm for decision tree is begin the tree with the root node says S, which contains the complete data set. Step 2, find the best attribute in the dataset using attribute selection measure. Step 3, divide the S into subsets that contain possible values for the best attributes. Step 4, generate the decision tree node which contains the best attribute. Step 5, recursively make new decision tree using the subsets of the dataset created in step 3. Continue this process until a stage is reached where you cannot further classify the nodes and call the final node as leaf nodes. So this is how our decision tree looks like. This is called the root node and these are the leaf nodes. Now, what is attribute selection measure? Explain three of them. An attribute selection measure is a heuristic for choosing the splitting test that best separates a given data partition D of class labeled training tuples into single classes. If it can split D into smaller partitions as per the result of the splitting criterion, ideally every partition can be pure, that is, some tuples that fall into the given partition can belong to the same class. Conceptually, the best splitting criterion is the most approximately result. In such a method, attribute selection measures are called splitting rules because they decide how the tuples at a given node are to be divided. The attribute selection measure supports a ranking for every attribute defining the given training tuples. The attribute having the best method for the measure is selected as the splitting attribute for the given tuple. If the splitting attribute is constant valued or if it is restricted to binary trees, accordingly either a split point or a splitting subset should also be decided as an element of the splitting criterion. The tree node generated for the partition D is labeled with the splitting criterion. Branches are increases for each result of the criterion and the tuples are isolated. Accordingly, there are three famous attribute selection measure including information gain, gain ratio and gain index. Information gain. Information gain is used for deciding the best feature attributes that render maximum dataset about a class. It follows the method of entropy while aiming at reducing the level of entropy starting from the root node to the leaf nodes. Let node n define or hold the tuple of partition D. The attribute with the largest information gain is selected as the splitting criterion for node n. This attribute minimizes the data required to define the tuples in the resulting subdivide and reflects the least randomness or impurity in this subdivide. Gain ratio. The information gain ratio is biased approaching test with several results. It can select attributes having higher number of values. For instance, consider an attribute that facilitates as a unique identifier including product ID. Split on product can result in a huge number of partitions, each one including only one tuple because each partition is authentic. The data needed to define dataset D based on these partitioning would be info product ID D equals 0. And third uh, measure is the Gini index. The Gini index can be used in CART. The Gini index calculates impurity of D, a data partition or calculation of training tuples S. Now question 3 is define a mathematical expression of information gain, Gini index and reduction in impurity. So the same answer answers our third question. Now the next question is explain concept of overfitting and tree pruning. So overfitting is an undesirable machine learning behavior that occurs when the machine learning model gives accurate prediction for training data but not for new data. When data scientists use machine learning models for making prediction, they first train the model on a known data set. Uh, and pruning in machine learning and data mining, pruning is a technique associated with decision trees. Pruning reduces the size of decision tree by removing parts of the tree that do not provide power to classify instances. So that was our second internal paper. Thank you.